Okay, ladies and gentlemen, in this video, our main goal is to prove a statement while utilizing the segment addition postulate. If you're really going to be kind of successful in this realm of type of proof, you of course have to be comfortable with what the segment addition postulate is. So just remember correctly that the segment addition postulate just basically tells us that if we have a big segment and it's divided up into smaller segments, I can add those smaller segments together to get the bigger segment. So we're going to utilize that to our advantage here today. So in this example, and let me first off by saying that this is not a one-size-fits-all type of proof. There are other methodologies for solving this proof, but I specifically want to tackle this proof by utilizing the segment addition postulate to see how we can kind of incorporate it into some future proofs as well. So of course, we're going to start off with what is given to us. So we know that AB is congruent to CD. So AB is congruent to CD, and of course, that is what is given to us here. All right, so again, when we start our proofs, think about what it physically means to be AB congruent to CD. Well, it physically means that AB equals CD in length. That is our definition of congruent segments. So AB equals CD. Now, where does the topic of segment addition postulate come on into play? Well, if we look at what we're trying to prove, we are trying to prove that AC is congruent to BD. So what I always tell my students is that if that's what you're trying to prove, you need to incorporate them somehow. AC and BD need to find their place into your actual proof. If they don't, they'll never be proven congruent. So what does it tell us? Well, I know for a fact that AC is actually equal to AB plus BC, and I also know that BD is equal to BC plus CD. And what told me that? Well, in both of those, that is from our segment addition postulate. Our segment addition postulate. Well, what did we already state, however, about AB and CD? We already stated that they were equal to one another. So if you remember correctly, when we stated they're equal to one another, that gives us the freedom to interchange, substitute, swap out, however you want to think about it, at any time. And if BC is already the same, AB and CD are the same, AC equals BD might not be too hard to find. Because if I go ahead and say that BD also equals BC plus AB, all I did was substitution property of equality. All I did was substitute AB, and CD. And now, if you notice here, I have that AC is AB plus BC, BD is BC plus AB, excuse me, and so that means that AC actually equals BD by our transitive property of equality. Technically, I guess substitution may work as well too in that case, so you kind of have a little bit of a freedom. I think transitive property works a little bit better in this situation. And now we have that AC, the segment, is congruent to BD, the segment, by the definition of congruent segments. And that, ladies and gentlemen, is a proof in which we have incorporated and utilized the segment addition postulate.